All right. So the first question says to define Coulomb's law. So you either write this and you tell me F equals electrostatic force, Q equals charges, and R equals distance between the charges. This will earn you your full 4 points. Or you can tell me that, you can write it down and say Coulomb's law states that the electrostatic force between charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So this will also earn you 4 points. So either one of these is good. That's straightforward. Guys, as I'm going through this, if you have any questions, feel free to stop me and ask. All right, the second problem asks to list 3 properties of charges. A lot of students told me something that says additive properties. I do not know what that means. I don't know where you guys get that from. It baffles me. All right, that's too much videos. Let's turn this off. Okay. Yeah. So it does baffle me. I don't know where you get that from. Additive properties is not part of it. So if you put something like that, you lose points. So the properties of charges are: 1, light charges repel, unlike charges attract. 2, or B, charges are conserved. And C, charges are quantized. If you give me all these 3, you get 4 points. If you give me 2 of the 3, you get 3 points. If you give me only 1, you get 1.5 points, and so on. Number 3, define electric potential. So the definition, we said electric potential V equals negative work infinity per charge, which is the same thing as U per charge. So if you write any one of these, as long as you tell me that negative work infinity is work done to bring a charge from infinity to point of measurement. And you tell me that Q equals charge. That will earn you your 4 points. Or if you tell me U divided by Q, where U equals electric potential energy, you get your 4 points. Or if you simply tell me that electric potential is electric potential energy per unit charge, that is putting it in words, saying that electric potential is the electric potential energy per unit charge. Or if you tell me it's the negative work done per unit charge, or negative work done to move a unit charge from infinity to point of measurement. If you put that in words, you get your 4 points. Anything else, you get either 0 or partial credits. All right, any questions? So what's the next problem? What is electric flux? So electric flux, you can define it in many ways. Epsilon naught flux equals QENC. That's Gauss's law. So from this, flux can be enclosed charge per epsilon naught. If you write this, as long as you tell me that this is flux, this is enclosed charge, and this is epsilon naught, you get your full points. If you tell me that the flux is the amount of electric field piercing a unit area of a Gaussian surface, you also get your 4 points. Anything other than this, it's either partial points or 0. Next in line, what is linear charge density? That's very simple and straightforward. It's the charge per unit length. If you tell me that, you get 4. If you tell me something that, if you tell me that in other words, as long as it's true, you get your full points. Anything other than that, you either get partial or 0. By the way, I have graded all of the first parts for everybody, as I'll post it right after this class so you guys can go over it. And I'm almost done with the second part. What is electrostatic force? So electrostatic force from Coulomb's law is the KQ1 Q2 divided by R squared. If you tell me this and you tell me all the terms, then you get full points. If you tell me that it is the force of attraction between charged particles due to electric field, you get full points. Anything other than this is either partial or 0. All right. I hope you guys are still with me. Yes or yes? Or yes or no in this case. Okay, good. What's the next question? Electric field lines. Almost everybody got this wrong, and it's a shame. Electric field lines. So when I was grading this, there was something I saw a lot of. How did you guys put it? Something like vector field. Oh yeah, vector field. Please tell me, guys, where did you get that from? vector field, because I do not know what a vector, I mean, I know what a vector field is, but has nothing to do with electric field lines. So where did you get vector field from? Almost everybody defined electric field lines as vector field. It's not vector field. Electric field lines, so if you put vector field, you either get 0 or partial points depending on how you describe it. But electric field lines are lines that help us, or that we use to visualize the magnitude and direction of electric field. That's it, nothing else. So many of you never mentioned electric field. You did not tell me that we use electric field lines to have an idea of electric field. Some of you said there are imaginary lines. I did not mark you wrong for that, even though that's not entirely true, because we've conducted research that actually shows the electric field lines are as we describe them. So they're not imaginary, they are real. They are invisible to the naked eye, but aha, that's good to know. You know what? Let me just Google that and see what it says. Electric field lines. That's true. Wow. All right. So I'll go back in, and anybody that has vector field will be labeled as cheating. And that's fair, because in reality, I never for once mentioned vector field in class. So for you to put vector field in your notes, that means you looked it up during the exam, and that is cheating. So that would have their, how do you say that, dire consequences. Yeah, so I just looked up Google, and it's so true. It says a feed line is a graphical visual aid for visualizing vector feeds. It consists of a directed line which is tangent to the field vector at each point. Oh my God. Interesting, because, oh wow. So I mentioned vector field. When I looked at Google, it also said something about tangent to the field vector. Tangent So if I see this in your paper, that means you cheated. So now I would go back. So sorry, I'm not going to post it immediately. I would go over this. If I see vector field, or I see tangent to field vector, you have to answer for that. All right? I gave you this ahead, and everything is in the notes, it's in the PowerPoint slides, and you had enough time to go through it. You don't need to do this. All right. Next. Describe a dipole and list one example. Let me see what Google says about dipole. Dipole. Interesting. So Google says that electric dipole deals with the separation of the positive and negative charges. I promise you, I have those exact words in your answers. Deals with the separation So I'll go back over this. If I see anything that looks like this, that will be cheating, and the consequences will follow. All right. Because when I describe electric dipole to you, my definition is that how do you know they cheated? And that's not just what they studied, though. Yeah. To that, my answer is yada, yada, yada. All right. So, back to where was I? Okay, so what are electric? No, we talked about electric field lines. Dipole. The way I define dipole to you is that a dipole is a system that consists of two charges of equal magnitude that are separated by some distance. All right, let me go back to Google and see what Google says. I'm going to type example of dipole on Google. Okay. Yeah, it shows water, but I also gave you that example, so that's fine. So example is water, common salt, hydrochloric acid, and so on. So these are things that can dissociate into H plus and OH minus, can dissociate into sodium plus and chlorine minus. So these are two charges, two charged particles of equal charges, elementary charges, that are separated by some small distance. And then this is H plus, Cl minus. Yeah. So those are examples. I think most of you did good with that, but still some of you could not define it. So last but not the least, what is elementary charge? And that's simply the charge on an elementary particle. E.g. proton, charge on a proton or electron. If you tell me it's the charge on a neutron, that would be super wrong. All right, any questions about the first part before we move on to the second part? Any questions about the first part? Guys, any questions? Okay, I just want to make sure you guys are there. So if you have a question, type yes on the chat. If you don't have a question, type no. And if you don't type either yes or no, then you are not in class and you would not get the participation points for today. Okay, so I have 7 out of 13. 8, 9 out of 13. So 4 students, just 10. There are 3 students that logged in but are not there. All right, thank you. That would be my attendance for today. So if, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Yeah. So let's move on to the second part. All right, that's an easier way to erase the board. So for this second part, you guys would refer to the questions that you had screen captured earlier. So the first question says, 2 like and equal charges are at a distance of 4 centimeters and exert a force of 7 times 10 raised to power negative 4 Newton on each other. Find the magnitude of each charge. All right. So here you use Coulomb's law, F equals K Q1 Q2 divided by R squared. Now, what are you looking for? You're looking for Q. So you know those are 2 equal charges. So you can rewrite this as K Q squared, magnitude of course, divided by R squared. And then you rearrange for Q's. So your Q squared would be, if you do cross multiplication, that would be F multiplied by R squared divided by K. And your Q would be the square root of this whole bunch. So now you can put in the values. F is 7 times 10 raised to power negative 4 times, notice the distance is 4 centimeters. So you convert that to meter, 0.04. And then that's R squared. So that's squared divided by K. And your K you are given as 8.99 multiplied by 10 raised to power 9 Newton meter squared per Coulomb squared. So you find the square root of whatever you get here. And you should get something that looks like 1.116 times 10 raised to power negative 8 Coulomb. If you do that, you get 15 points. Now, if you get the answer wrong, but you get it set up correct and you get this correct, then you just lose a few points for not knowing how to work a calculator. If you get it set up wrong, then that's a big problem. If you don't even know what formula to start with, then that's a bigger problem. All right, so that's number one. Number two, you have a disk of radius 3.5 centimeters that has a surface charge density of 6.3 microcoulomb per meter square on its upper face. What is the magnitude of the electric field produced by the disk at a point on a central axis at distance z equals 12 centimeters? So let's see, what do you have? You have radius equals 3.5 centimeters, which you have to convert to meters. That would be 0.035 meters. What else do you have? You have z as 12 centimeters, which is 0.12 meter. And then you're given surface charge density, sigma, as 6.3 microcoulomb times 10 raised to power negative 6 coulomb per meter squared. That's charge per area. What else do you have? That's it. And what are you looking for? You're looking for E. Well, you can simply use this formula. E equals sigma divided by 2 epsilon naught 1 minus z over z squared plus r squared. Yeah, and you plug in the values, you have your sigma is 6.3 times 10 raised to power negative 6 divided by 2 multiplied by epsilon naught 2 times 8.85 times 10 raised to power negative 12. That's the value of epsilon naught that's given. Multiplied by 1 minus your z is 0.12 divided by 0.12 squared plus 0.035 square. And that's it. So you punch your calculator and you get an answer. I haven't worked this out yet, but all I have to do is just punch a calculator and I'll get an answer. Any questions? So if you set it up, if you get the equation correct, you earn some points. If you insert the values correctly, you earn some points. And if you punch your calculator correctly, you earn some points, and everything will add up to 15. All right, let's move on. Number 3. 2 protons are placed at a distance d over 2 directly above the center of the square of side D. What is the magnitude of the electric flux through the square? So you guys, you did something just like this in your homework problem. Really, all of these problems are from your homework problems. What did you do? Here, you use Gauss's law, epsilon naught phi equals Q ENC. What are you looking for? Electric flux. So if you rearrange, your flux would be Q ENC divided by epsilon naught. Now, this flux is the flux through the O cube, right? So this is your particle, this is your d over 2, and right here you have your side. So you can draw all the other sides, and okay. So this flux that you have is the flux on the entire entire cube. Now your QENC, your flux will be equal to, what's the enclosed charge? The question says 2 protons. So your Q would be equal to 2 multiplied by elementary charge. So your flux would be 2 multiplied by E. What is E? 1.602 times 10 raised to power negative, no, times 10 raised to power 19. Is it 19 or negative 19? It should be negative 19. I might have given you that wrong because it can't be that big. Yeah, I think it's negative 19. So that divided by epsilon naught, which is 8.85 times 10 raised to power negative 12 Newton meter Coulomb square per Newton meter square. All right, so with this would be the flux for the entire cube, but you only need one side. So one side of this would be for one square. So flux for square will be equal to 1/6 multiplied by 2 times E divided by epsilon naught. So that will cancel out. So that will simply be 1/, so that will simply be epsilon naught E elementary charge divided by 3 epsilon naught. All right, and then you plug in the values and you get an answer. Any questions so far? All right, let's move on. Number 4. So you're given the electric field above the surface of a charge conducting drum of a photocopying machine as E equals 2.1 times 10 raised to power 5 Newton per Coulomb. What is the surface charge density of the drum? This is very straightforward. You know that E equals sigma divided by epsilon naught, where E is electric field, sigma is the surface charge density, and epsilon naught is the permittivity constant. Rearrange, and this would give you E multiplied by epsilon naught. And you're given your E, you know your epsilon naught, so you simply plug those in, and that would be, what's your E? 2.1 times 10 raised to the power 5 multiplied by, what's your epsilon naught? 8.85 times 10 raised to the power negative 12 Coulomb square per Newton meter square. All right, so you punch your calculator. I have not punched mine, but you punch your calculator and you get an answer. Again, if you do all this correctly, you score 15 points. I also give partial credit. Number 5. A point charge of 2 microcoulomb is at the center of a cubical Gaussian surface of edge 40 centimeters. What is the net electric flux through the surface? So again, you're looking for flux, and then from Gauss's law, epsilon naught flux equals QENC. Rearrange, your flux will be QENC divided by epsilon naught. All right, and so what's the enclosed charge? 2 microcoulomb. Your Q equals 2 times 10 raised to the power negative 6 coulomb, and then you know your epsilon naught. So you simply say your flux is 2 times 10 raised to the power negative 6 column divided by 8.85 times 10 raised to the power negative 12, and you punch your calculator and you get an answer. Number 6. What must be the distance between point charge Q1 equals 25 microcoulomb and Q2 equals negative 35 microcoulomb for the electrostatic force between them to have a magnitude of 5.7 Newton? Simple question. Again, you use Coulomb's law, F equals KQQ by R square, magnitude. That's it. And what are you looking for? What must be the distance between them? So you rearrange to make R the subject of the formula. So this F over 1, you do cross multiplication. Your R square would be KQQ, Q1, Q2, divided by F. And then your R would be the square root of this bunch. Okay. So with this, you punch in the values that you're given, and that will give you so your R will be equal to the square root of 8.99 times 10 raised to the power 9 multiplied by the first charge Q1 is 25 microcoulombs, so that's 25 times 10 raised to the power negative 6 coulomb multiplied by the second charge is negative 35, but we're concerned about the absolute value, so we just say 35 times 10 raised to the power negative 6 divide by the force of attraction, which is 5.7 Newton, and then you find the square root of all of this. And you punch your calculator and you get an answer, and that would earn you 15 points. So I'll take 4 of these 6 questions, and those will constitute your grade. Any question? All right, so in the absence of any questions, I will take the attendance, which I already did from you guys answering if you were here or not. I'm just pulling up my class roll, and I would use that to take attendance. So while I'm taking the attendance, think about the exam, and let me know if you have any questions. And I also need to apologize. I gave you problems that were so simple. So I'm so sorry for giving you super easy problems. Next time I'll try to do better, okay? March 8th, 3/8. Okay, so Michael is in class. Vivian is in class. Ariel is in class. Cameron is in class. Daniel is in class. Crystal is in class. Justin is in class. Tia is in class. Gregory is in class. Jonathan is in class. Oh, hold on.